That's clear. Okay. We are now going to move on to chapter 16.7. 16.7 is actually in two parts. Both are calculating what's called the surface area. It's a surface integral. And so we're going to calculate an integral, a double integral, on some three-dimensional function, a surface. So can you imagine this is D on the bottom, and you project this up onto surface, and you've got this little curved surface area. And inside this surface area, we're adding up all the values of the function. So it's a surface integral, as it's called. I think I knew the name, and now it's gone out my head. There's actually a physical thing that's equal to a surface integral. And it's just totally escaped me. I think, don't quote me on this, because this term might be for something else, but I believe it's called the flux, F-L-U-X. You're nodding like you've heard that term well.
Yes. So yeah, in a lot of engineering and physics, you have fluxes, which are basically the amount of something leaving or entering a volume. And you basically, in order to find that, you integrate that motion of something. It can be a magnetic field, neutrons, whatever, across the surfaces that make up that area.
Also, I did get the name right.
Yeah.
Does this double integral kind of look like it would be calculating that?
Oh, absolutely. You basically just add up several surface integrals, or just one depending on whatever surface. It can be a box, and a sphere. It can be. Normally, you just define it to be something convenient. Mm-hmm. And back in high school physics, you did it with very simplistic shapes and stuff that always worked out nicely to work like right angles. So you never actually had to integrate it, but they'd always say, "Yeah, you do a surface integral for this," and we're not going to mention what a surface integral is.
Oh, so now you finally get to know what they said. We're not going to mention it.
Yeah.
Well, I'll be interested to see how this goes then. So there are two versions of how to calculate this. The first 5 questions, I finally rearranged them so they are the first 5 questions, are going to use this formula here. So what you have to do is you have to rearrange the equation of the surface so that it's written as z equals a function of x and y. So I'm calling it g of x of y, right? So z equals x squared plus y squared, right? Something like that. Once you've rearranged the equation of the surface, then this double integral, this surface integral, can be found by a double integral of the function f, x, y, z, and that's basically going to be whatever this is, right? Times a weird looking square root, which is made up of the square root of this guy's derivative with respect to x squared, plus this guy's derivative with respect to y squared, technically plus this guy's derivative with respect to z, which ends up being 1 squared. So that is the guy. This is the go-to kind of equation that is going to find this surface integral. So
multiplication by the square root? Or is that minus?
Yeah, this is a multiplication. Kind of, yeah, more dot-like now. So
I'm glad I'm not the only one who saw a minus sign.
That's just me and my writing. So here is a surface integral. The function is xz ds. You're told that the plane, or the equation that we're going to deal with, is 2x. Oh, shooting space. That one's question 4, and I will do that later. But that's not the easier one. I want to do an easier one before we do something like that. So let me do one, or a version of it. We're going to do the double integral, or surface integral, and it's x squared yz ds. Okay, that's fine. Z is going to be called, the surface is going to be called z equals 1 plus 2x plus 2y. And this region D would be what you'd get if you projected onto the floor. And D is a nice simple box like you were talking about, well, at least to start the ball rolling, right? So that basically means x from 0 to 2, and this is y from 0 to 2. This guy here, let's put names on things. This guy here is the fellow that we're going to call g of xy, right? Now, if it wasn't written like that, you know, it could have been written as 2x plus 2y minus z equals -1. If it was written that way, you would rearrange it to be z equals, and whatever the z was equal to, the whole package is your g of xy. Now, in this case then, that double integral is going to equal x squared y, and instead of z, you replace it with that. So that's 1 plus 2x plus 2y. So that's basically this bit times the square root of, if you differentiate this with respect to x, you get 2 and you square it. With respect to y, you get 2 and you square it, plus 1 dA. And that's going to be over region D. So it's going to be x squared y plus 2x cubed y plus 2x squared y squared. That's the square root of 9, which is 3, so I'll just pull it out here. And dA, I'm going to replace it by a dx dy. And it's going to be from x equals 0 to x equals 2, and from y equals 0 to y equals 2. So this surface integral, when you convert it using this formula to a double integral over this region here is what D is, you get this double integral. Is it okay for me to do a dot, dot, dot in this, or do you want me to do this double integral? You want to see it as a calculation?
Yes, please. Yes,
Okay,
please.
let's keep going. So it's going to be the integral from y equals 0 to y equals 2. If you integrate this with respect to x, what do you get? You get 1/3 x cubed y plus 1/2 x to the 4 y plus 2/3 x cubed y squared, evaluated from x equals 0 to x equals 2, and then you can do the dy bit. So it's going to be y equals 0 to y equals 2. If you plug in 2, what do you get? You get 8/3 y. If you plug in 2, you get 2, 4, 8, 16, you get 8y. And if you plug in 2, you get 2, 4, 8, you get 16/3 y squared. And then I would tidy it up just a little bit. That and that gets you 24, that gets you 32/3 y plus 16/3 y squared. And now you have a calc 2, 1. So here it goes. Add 1 to the power and then divide by the new power. That gets me 16/3 y squared. Add 1 to the power and then divide. You get 16/9 y cubed. Evaluated at 0 and equals 2. By the way, when I did this answer here, technically take away 0 was taking away a whole load of nothing, so I didn't write it down. Same thing's going to happen here then. It's going to be 2, 4, 64/3. 2, 4, oh God, 64 times 2, 128/9. Take away a whole load of nothings. That's going to get you 192, 392, 402, 412, 400. Too hard.
Could we factor out that 3 before going
I
on
guess
there?
that might help. If I factor out a 3, it'll cancel. So I'll get 64 plus 128/3 will be easy to deal with. 3 times 64. 3 times 64 plus 128 is 320 thirds. Don't think that simplifies. Right. That's the process. If something doesn't add up, it's just I can't count. The hardest part to me is actually just setting this up. If you set this up, it just turns into a double integral like you'd be doing forever in the day. And these are the ones with numbers. Of course, it's going to get harder as the questions progress, but that would be the one for that one. And I just missed a question there. Okay, you don't belong there. Question 2 does not belong in this group. So there's only 4 of these. Question 2 belongs in the second method, but I'll figure that out later. So don't pay too much attention to my numbering system because it's going to be a little bit out. So this one is a double integral of y, right? It's that surface integral. Z is 2/3 x to the 2/3 plus y to the 2/3, and d is basically 0 to 4 and 0 to 2. So that's the package. So we're going to do a double integral over this region D, and the function f is this guy. And this guy doesn't have any z's in it, so it's actually just going to be y, followed by the derivative of this fella with respect to x and square it. Right, you don't need that guy, so you're going to get 4/9 x. Okay, let's put that in. 4/9 x to the negative 1/3 and square it, and then you're going to get 4/9 y to the negative 1/3. Now you're going to square it. dA. Yeah, I did not like the looks of this. You're going to get 1681s x to negative 2/3, and you're going to get 1681s y to the negative 2/3, and you're going to have a dA. Oh, no wonder it's ugly. I apologize. I should do my scanning better. Somehow 2/3 turned into 3/2. There we go. Right, so pretend that last 2 minutes didn't happen. Same everything else, just that's 3/2. That's going to make the question actually doable. So it's going to be a double integral over some region D of y. Now, if you do this fella, you basically just get x to the half squared. And if you do this fella, you get y to the half squared. And that's much nicer. You basically just get
+1.
Oh, +1. Thank you. You got that guy. Okay.
Do you have to multiply the y by the z also, or?
No, this bit here just means take whatever the function is and replace the z in this function, right? So if there was a z in this, it would get replaced by that. Since this function doesn't have a z, we don't really have anything to worry about.
Oh, I see.
See, if this was xz or yz, then I'd have y and that ugly mess. Our integral is going to go, I'm putting dy there. Well, I can. Why don't I just get my right hands and put in both of them then, because you need both. And since I'm doing it in, what are they doing it in? Yeah. I'm going to switch my order. Do the x's before the y's. And x's are going to go from 0 to 4, and y's are going to go from 0s to 2. When I leave today, I'm going to go and get a whole load of pens. All my good pens are gone, and I don't like these pens. I don't write well with them for some weird reason. Don't know why. So I'm going to do this integral here first. Now, with respect to x, I guess I could do one more line. Yeah, see, they just don't write nice. They have a funny drag on them. There we are. If you do this with respect to x, it's a little bit easier than if I tried it with y. That's why I switched my order. So it's going to be y equals 0 to y equals 2. That y is still there. Add 1 to the power and divide by the new power. So I'm going to get x add y plus 1, add 1 to the power, and then divide by the new power. And then I'm going to evaluate it from x equals 0 to x equals 4. We plug in 4, I get 2/3 y, y plus 5 to 3/2. Take away, if you plug in, question?
How are we not having to deal with some other term of x coming out of the
Yeah.
x plus y plus 1 to the
Well,
1/2?
we are, but the derivative of that is just times 1, so I'm not bothered. If you if you take this, it's basically just 1x, and 1x doesn't give you anything. Technically, there's a times 1 here, but I'm not writing it down. Now, if that was 2x plus y plus 1, wouldn't I do a times 1/2 here? Right, but since it's x plus y plus 1, it only introduces a times 1, which doesn't affect anything. Right, if you plug in 0, you get 2/3 y plus 1 to the power of 3/2. And now you've got that integral to do. Okay. And this is going to have to be done a little bit in a special way. So let me pick one of them just to show you what to do. Suppose I wanted to find the integral from 0 to 2 of 2/3 y plus 5 to 3/2. Terence, I'm not sure, did I actually explain what we just did a second ago? You know, that there is a 1 there, I just didn't write it. Are you still not?
No, I'm completely lost as to
Okay.
how there is not another x term popping out of that x plus y plus 1, because
Okay.
we're
Right, let's,
integrating, which means powers are supposed to go up, not down, I thought.
well, they do go up. So let's integrate this guy. This is the original, right? Okay. Add 1 to the power. And divide by the new power. Are you comfortable with what I've written so far? See, this is a constant. This is like 5 times something, right? So that y doesn't take part in any meaningful way, right?
Yeah,
so
I'm not.
right.
My problem
Now,
is not with
okay,
the y. It's with the x's.
okay. Right. What do we do about the x plus y plus 1? Right. That's the problem. What I'm trying to say is that should be 1. And since it's times 1, I didn't bother writing it down. If I gave you 2x plus 3y plus 77 to 1/2, you would add 1 to the power. You divide by the new power, and you'd get that. But you would also get an extra times a half because of that 2x. What about the 3y? Doesn't matter. What about the 77? Also doesn't matter because constants don't have any effect, only things with x's. So that one would have had a times a half and this one wouldn't.
I think maybe it's the whole remembering you've got to do a derivative, then integrate.
Well, the derivative you do is that number that goes there as a fraction. Okay, if I went and said to you, I want x plus 3, right? I wanted to integrate just x plus 3. You would call it x plus 3 to the half. And it's basically an integration stroke chain rule situation. So what you can do here is you can add 1 to the power, divide by the new power, and in this case, you're finished. And if you want to check, differentiate what I've just written, and I bet you get that. Now, if there was a number like 3x involved, you would add 1 to the power, you divide by the new power, and then that 3x would get you an extra times a third. We're using the trick that we used in Calc 2. If that trick doesn't work for you, do a U sub. Call U equals x plus 3, and trust me, it works. So I'm not sure if you've picked up a rule that's not true, or you've confused a rule that you've used and wondering why it's not there anymore, why it's not happening.
It's more confusion on my fault, and thank you everybody for putting up with me.
No, I hope we can go back and have a little look at those types of questions, and maybe it'll click in, because that's the best way to do it. Right, we've got 2 really ugly guys to find the integral of from 0 to 2. I'm only picking this one, and then you could do this one separately. Calc 2.
Oh, what would the U sub?
Well, you nailed it. What U sub would you use in a question like this?
U would be just the 2/3 y. Or just
No.
y,
Nope.
pull out the 2/3.
No, think a different one. Go a different way than the way you just said. Not 2/3 y. Who should your U sub be? It is a U sub, but not that
The
guy.
y plus 5.
It is. Now, this U sub doesn't look like it's going to work, but it will work, trust me. If you do a differentiation, you get 1. If you do a crossover, you get that. So this integral becomes 2/3 y u to the 3 upon 2 du. And you're right, dy gets that, this begins that. And you've got this really ugly 2/3 y left over. And you might think, well, that's it. That can't be a good U sub because you should never have the other variable left over. But what you do is you return back to here. And you subtract 5 from both sides. And that means that this can now be 2/3 u take away 5 times a u to the 3/2 du. And then again, you'll try and talk yourself out of it. You're going to say, ugly square root, 3/2, can't do it. Different looking ugly square root with 3/2, can't do it. That's not true. You can do this one. But you just have to do a little bit more work. What do you do next here?
Distribute.
And 2/3 u times that gets you 2/3 u to the 5/2, and 2/3 times that gets you negative 10/3 u to the 3 upon 2. So what might have looked like a relatively simple question, hasn't this grown into some really ugly monster of a question? Now, add 1 to the power, 7/2. Divide by 7/2 is the same as 2/7, so I make that 4/21s. Add 1 to the power, 5/2. Divide by 5/2 is the same as multiplying by 2/5. The fifths and fifths cancel, I believe you get 4/3. Convert back into the original. And the original was y equals 0 to y equals 2. And eventually, won't that become a number and you'll get the answer? So we're bringing up special integrations from Calc 2, how to integrate things that look like these guys here, right? Are we good? There's one and only one saving grace. There's not a lot of. This one is the last one of the, is it? No. Second last one. My numbering's all higgledy-piggledy because of that question that is in the wrong place. So we want to do a surface integral. And the guy that we've got is xz ds, right? That's the surface integral. And the surface that we're dealing with is 2x plus 2y plus z equals 4. And it's in the first octant. That is not going to be nice, because if we want to do this, we need to find out how to deal with that information, because the way they've given it is not really conducive to using this formula. Part of it is. Let's start with the easier one. If you tell me that the surface is called that, then if I rearrange it, we've got that. So I now know what I call g of xy is, right? And this fella up here is called xz. So that's going to be a double integral. X and z is this guy. Times the square root of. Differentiate this with respect to x and you get -2 and you square it. Differentiate this and you get -2 and square it, plus 1 dA. And that now becomes the double integral over some region d of, what's that, 4x, take away 2x squared, take away 2xy. And that's, well, 9 again, 9 gets you 3, I'll stick the 3 out there, dA. So what's the problem? The problem is I don't know who D is, right? The guy on the floor. All I know is it's this surface when it meets the first octant. Now you know this guy is a plane, right? And you know the first octant is when the x, the y, and the z are all positive, right? It's in this 8th part of the universe, right? Around the quadrant that are called octants. So I'm going to take this equation of the plane and I am going to find where it cuts the z, the x, and the y axis. In particular, I'm really only interested in where it cuts the x and y axis, because that's going to be the floor, right? And the floor is going to be the D that we need. So let's see what happens. If you make y and z 0, you get x equals 2. If you make those two, you get, there we go, you make y equals 2. And if you wanted to know what z is, it's up here as 4. But the key to it is, I'll put the whole thing in, isn't that little guy on the floor the D? You see how I found the region on the floor that's going to project upwards to give me my surface integral. Now that fella, if I then reorientate it in a way that makes more sense to us, it starts at 0 and it goes from 2 to 2, right? That's the region D. I'm going to do my vertical guy, and it scans from 0 to 2. And the y is going to go from the bottom, which is 0. And isn't the top just the equation of the straight line? That's actually pretty easy to do. Anybody want to tell me what the equation of this line would be? And that's what fits there.
Wouldn't it be
Negative
negative
X.
X?
Say again?
Negative
Anybody?
X?
You may have said something, I just
X
didn't
plus
catch it.
2.
Is it a +2 or a -2? Or a negative X and a +2? There's some
Negative X
negatives go-
plus 2.
Agreed. You all agree on that, or 2 minus X if you want to call it that? Right, we got everything because we already know what this guy is. So I'm going to put him in. So it's going to be 3 times the integral of y from 0 to negative X add 2, and then X going from 0 to 2. And it's going to be for 4x, take away 2x squared, take away 2xy. And we'll do y first and x second. Would you agree that's a pretty standard double integral that we've done for lots of situations? Why did I write it with the y's before the x's? Because that's the only order that makes sense.
Because of the equation.
And the equation of y, I'm assuming you mean?
There's a variable. There's
Right.
X.
Right. So if something's got a variable, doesn't that have to be done before the things that have numbers? Because the last one always has to be that. So was I just power rule, ridiculously ugly answer, and you're done. And we do have time for one last question. And tomorrow we'll look at the second method for calculating surface integrals. Right. This one is a particular method for particular information. This one, the surface integral, is x ds. I suspect very strongly that they make these very simple integrals because the math ends up being really ugly, even in very simple questions. So if you made that really ugly, you'd probably end up pulling your hair out. The equation would just grow. Now, S is a triangular region. And it's a triangular region made up of that guy meeting up with that guy, meeting up with that guy. So I'm now going to try and imagine what they're talking about. So 1, 0, 0 would be here. Great. 0, negative 2 would be here. And 0, 0, 6 would be up here. So the region that they're talking about is that region there. It's horrible to draw things in 3D, right? It just is. Okay. Now, we have two main issues. The first is a major one. I need to know the equation of this plane. And all I know is it passes through 3 points. But I want to know the equation of it, right? Now, there are two ways to do it. The first way is how you would have been taught in Calc 3, which will work. Well, don't you find PQ, PR, cross product, that gives you the normal, pick a point, find the equation of the line, off you go. I'm going to do a different way, a shortcut. Aren't all equations in the world, basically all planes in the world, aren't they written as AX plus BY plus CZ equals 6? Isn't that the way they're written, right? Okay. So first thing I'm going to do is I'm going to rewrite it like that. And you might say, what happened to the C? Why did it turn into 1? And why are the others untouched? Since these are any numbers in the universe, couldn't I divide everybody by C and get A over C, B over C, and D over C? And since I don't know what those are, couldn't I call it A, B, and D, right? Are you okay with that little cheat? I can do that. Now, if I take this point, AX plus BY plus Z equals D, what we get is nothing plus 6 is equal to D. Oh, so I now know what D is. So my equation is AX plus BY plus Z equals 6. If I use the top one, 1, 0, 0, I get A times 1 plus nothing equals 6. Oh, that makes A6. So I now have 6x plus by plus z equals 6. And if I use this one, I get nothing plus b times -2 plus nothing equals 6. And -2b equals 6. So b is -3. So I now know the equation. It is 6x take away 3y plus z equals 6. And that was just a little algebra trick to find the equation of a plane if you know 3 points. And the reason why this trick works is, do you notice that in this case, everybody has 2 zeros in our number. And that makes the algebra. If that was 1, 2, 3, and 5, 6, 7, and 8, 9, 10, you know, forget it. This trick wouldn't be of any great use to you. If I rearrange that then z is 6, take away 6x plus 3y. Okay, that's good. Now, if I return to my little picture again, as badly as I have drawn it, this guy on the floor isn't AD. What do I know about that fella on the floor? Well, he passes the x-axis at 1, and he passes through the y-axis at down here at -2. So the region we're talking about when you reorientate it is this region. And if I do my little vertical rectangle, I can tell you that x goes from 0 to 1. And that y goes, well, it finishes at 0. And this straight line here is 2x minus 2. So that's my region D. Right, we've got all the pieces. Let's put them together. And we're done. So the surface integral of x ds is going to become the double integral of x, because there's no z's involved, followed by the square root of, where's my equation? Here it is. Differentiate that with respect to x, you get -6 and you square it. With respect to y, you get 3 and you square it, plus 1. The region D is x equals 0 to x equals 1. y equals 2x take away 2 to y equals 0. 46. Okay, the square root of 46x dy dx. We're pretty much good to go then. That's the square root of 46xy. Y evaluated at 2x take away 2 to 0. Plug in 0, you get nothing. Take away the square root of 46x times 2x take away 2. That is a horrible thing. I'm just going to suck the whole thing out. Do the integral from 0 to 1 of 2x squared take away 2x dx. Can you imagine? That's just a really boring integral, but you'll get an answer. And according to what they've got, the answer is positive 46/3, which seems reasonable because that's a 46. I'm not quite sure where the third comes from, but that's probably going to be a negative, a third. And that negative make it a positive answer. Okay. And say your last name and bye-bye.
See you tomorrow.
Thank you. Bye.
Okay.
Bye.
Bye-bye, guys.
Bye, thanks.
You're welcome.
Thanks for putting up with my digressions. Have a good
No,
day.
you are not. No, don't even think that. You know, try to help. If you've got a concept that's not hitting right, you got to figure out a way of fixing it. So that's what you need to do. Okay, we are out of here, Tim, unless you've got a question, because I'm gone. Okay, bye-bye.